All right, so as you can see, we're heading back in lesson 3. We're going to talk about volume again, take a little break from surface area now. And we're going to go back to some background knowledge we have. So far, we've done the volume of prisms and cylinders. Now you can see, if you're a visual person, you can see where we're going to go with the volume of pyramids and cones. I'm going to show you, thanks to the wonders of YouTube, I'll show you a presentation from someone else that I would normally do in class with you that really helps you with this. If you follow the presentation closely, you should be able to come up with the formula for the volume of pyramids and cones on your own, as long as you still have that same background knowledge of what we did before. Remember, before when we were working, we always found the volume of prisms to be base area times height. Found the area of the base, we took it times the height, then we could find the volume of prisms and we could find the volumes of cylinders. Now we're going to work on pyramids and cones, and hopefully this video will help you through this idea. So let's watch this. Thanks again to the wonders of YouTube, like I say. You see that we have a cone, and we're going to compare this actually to a cylinder. And the relationship between these two solids is going to be pretty important to the formula that we come up with for cones and pyramids. And so as you watch them work through this demonstration, notice some of the things that are the same, notice how they relate to each other, and notice how we can actually lead this to our formula. So one thing you should notice right away, it says they have the same base area. For a cone and for a cylinder, remember that base is always going to be the circle. We've already talked about that. We know that it's a circle. But so what that means is those two circles are congruent. They have the same radius, they have the same diameter, they have the same circumference, they have the same area. Then the other thing you notice with the cone and the cylinder is that they have the same height. So not only was their base the same, their circle was the same, but they also had the same height. And that's obviously going to be pretty critical for this to work. But if I take the cone with the same base area and I take it the same height as a cylinder that we've already worked with, then we'll see how this relationship leads to the formula that we're going to talk about today. Remember, while he's working on filling up his bucket with this beautiful green water, as he's working with this cone, he's filled up the cone all the way up with the water, and he's going to start transferring that over to the cylinder, and you should start to notice the relationship that relates between the cone and the cylinder. The other thing to keep in mind is, as you see this, is we already do know how to find the volume of a cylinder. To find the volume of a cylinder is just like a prism. We said base area times height. But since we also talked about cylinders, the base is always a circle, we said instead of saying base area times height, we could actually say pi r squared times height, because we know the area of a circle is pi r squared. Something to keep in mind when we get to the cone example today in notes. Notice he's got 2 cones worth in the cylinder. It looks like he's getting towards the top. And now as you see this third cone get poured into the cylinder, you notice that the cylinder is all the way filled up. And so hopefully you notice what happened there. It took exactly 3 cones to fill up that cylinder. And that's going to be huge for what we talk about today in these notes. And in fact, I gave you a couple more visuals in your notes to try to help you with this too. It says if you were to put a cone or a pyramid into a prism with an equal base area and equal height, and again, that's critical, but that's what we saw in the video. They had the same base area, they had the same height. What you'd notice is that the cone or the pyramid takes up exactly 1/3 of the volume of the prism. So that's why it took 3 cones to fill up the cylinders, because it's 1/3 of the volume of that cylinder. They had the same base area, they had the same height, but their volume, it actually is 1/3 of the cylinder. Same is true for for pyramids. Doesn't matter if it's a rectangular pyramid, a square pyramid, a triangular pyramid, doesn't matter. If they have the same base area, they have the same height, the volume of the pyramid will be 1/3 of the prism. And I give you another visual on that on the next slide, but just trying to show you the same basic idea. If I filled up the cone and then I poured that into the cylinder, you see that the cone fills up exactly 1/3 of the cylinder, which leads us to everything that we needed to know. Back before, we already talked about this. We said, well, hey, volume is base area times height. Well, that's true for rectangular prisms, for triangular prisms, for cylinders. When we talk about pyramids and cones, because they take up exactly 1/3 of that prism, or 1/3 of that cylinder, the only thing we add now is to divide by 3. Take the base area times the height divided by 3. And so that's the next formula that you see in your notes. And this is really the only new thing that I'm showing you today. But so we do what we've always done, base area times height, but then to actually find the volume, we divide by 3. This is true for cones, this is true for any other type of pyramid, because of the relationship that exists. Find the area of the base, take times the height, divide by 3. We will also talk about on the last example how dividing by 3 can actually be put into a little bit different order, much like what we do with the area of a triangle and the area of a rectangle, and how you can divide by 2 at the end, or you can divide the base or the height by 2 early. We're going to talk about how you can change the order a little bit with the volume. The other thing we're going to talk about, and you'll see in both of these examples, is base area times height divided by 3 leads you to some situations that you got to be aware of as far as making sure your answer makes sense and rounding it when necessary. So here we go. I got a square pyramid. I can tell that it's a square pyramid because it says it's 5 by 5. So I have a square, and then notice I have the height of 10. Well, if we were doing it like normal, we would take base area times height. But now since it's a pyramid, or if it was a cone, now it's just base area times height divided by 3. So it works pretty similar. To find the area of the base, alright, I'm going to take 5 times 5. Base area times height would be 10. But now the new step that we added is we have to divide by 3. So 5 times 5 gives me 25, and 25 times 10 is 250. And normally, if this was just a rectangular pyramid with a base area of 25, we'd be done. But since it's a pyramid, we have to remember to divide by 3. So when we go to divide by 3 here, we're going to talk about some interesting things that happens when we divide by 3. You'll start to notice 3 goes into 25 8 times. 8 times 3 is 24. 3 goes into 10 3 times. 3 times 3 gives me 9. And I have one left. And so obviously we can make it a fraction answer. We could keep going. Typically what you're going to do is you're going to just go into a decimal. So I'm going to add a decimal and add a 0. And I'll bring that 0 down. And 3 goes into 10. I'll take my decimal up. 3 goes into 10 3 times. 3 times 3 is 9. I'm going to subtract 1. Hey, I'll add another 0. And then you should start to notice what happens here. If we want to keep going like this, that 3 is going to repeat forever. So now how do I make sure my answer makes sense? I don't need to do 83.3 repeating or something like that, like maybe you would do if you were just doing a division problem. For volume, I think it's totally fine to round. So whether we're going to round to the nearest tenth, nearest hundredth, whatever the case may be. For this one, let's round to the nearest tenth. So you see what we have here so far. To round to the nearest tenth, remember that means we're going to look at the 10th place. That's what we're going to round to. But in order to do that, we look at the number next to it. If it's below 5, if it's 1 through 4 or 0, we round down, meaning that number stays the same. If it's 5 or above, we round up. Well, in this case, since this is a 3, that tells us to round down. Remember, down doesn't mean to drop anything actually lower, but it does mean to get rid of this. And we can just say 83.3. We can round that way. Don't have a label as far as units. It doesn't say centimeters or inches or anything like that, but I can still say units. And then remember, the key is we're finding volume. And if we're finding volume, that's always going to still be units cubed. So we get 83.3 units cubed. We'll look at another pyramid problem. Happens to still be a square pyramid. It's 7 by 7 and then a height of 3.2. So again, base area times height divided by 3. 7 times 3.2. Don't forget to divide by 3. That's it. Base area times height divided by 3. 7 times 7 gives me 49. So I'm going to take 49 times 3.2, or 3 and 2 tenths. 9 times 2 is 18. I carry that. As you multiply, remember, as you go to the next digit, you need to put a 0 here for a placeholder. 9 times 3 is 27, and I carry that too. 4 times 3 is 12, plus 2 more is 14. If I'm going a little too fast on the multiplication, feel free to pause it, rewind it, whatever you need to do. But that is just 49 times 3 and 2 tenths. I do a little adding here. Get this thing cleaned up, and I got 156.8. Remember, that's however many decimal places there are after the decimal in your factors. 156.8, or 156 and 8 tenths. Remember now, the final step is still divide by 3. We've got to actually divide by 3. And so as I do my division, I'm checking along, and I'm making sure things are going okay. I get the 2 here as well. I can bring my decimal straight up. And then again, you're going to see some of that same stuff happen where I start adding zeros, and I start getting some repeating numbers. As I continue to add zeros, I continue to get a 6 here. So again, maybe we'll round to the nearest hundredth on this case to be precise. That's great. So I'm looking at the number that we have right now, 52.2666. I better put another 6 there. We'll go 4 6s. If we're going to round to the nearest hundredth, that means we're going to have 2 decimal places in our answer. So we look at the next one to the right. And now since it's above 5, that tells us to round up. So we're going to round this last number here up 1 and then drop the rest. And you'll see we should get 52 and 27 hundredths. Again, make sure your label's worth a point every single time. They give us centimeters here, and since we're finding volume, it's centimeters cubed. So 2 examples of using the base area times height divided by 3 for pyramids. But of course, I think the one that's always going to be a little bit trickier maybe is cones. So we'll look at one example of the cone. The other nice thing about this one is we'll talk about that trick we said where we can divide by 3 in a little bit different order to make it easier on us. So let's think about this. Remember, the solid that relates back to the cone is actually the cylinder. So remember, for the cylinder, we said, well, yeah, it's base area times height. But we also said, hey, I know what that base is. It's a circle. So instead of saying base area times height, we actually said pi r squared times height because that's the area of the circle times the height. Well, this is true for cones. We're going to say pi r squared times height. But again, it goes back to what we talked about. It's base area times height divided by 3. Remember, it was 1/3 of that cylinder. So we're going to divide by 3 here. Pi r squared h divided by 3. Can plug in 3.14 as an approximation for pi. For our radius here, it looks like we have a radius of 8 centimeters. So we have pi r squared. Then our height is 18. And then, of course, we're still going to divide by 3. Now, here's an example of one that we've talked about where we can change the order up a little bit. Can't change the order at first. We got 8 squared. Got to do that. That's 8 times 8, which is 64. And I have 3.14 times 64. So 4 times 4 gives me 16. I carry the 1. That makes it a 5. And then I've got 12. Put a 0 here, 24. Carry the 2. 1 times 6 plus 2 more is 8. And then 3 times 6 is 18. Add these all up. I get 6, 9, carry some ones around, and I see two numbers after the decimal place, so 200.96. Now, if we were going to go in the normal order and just keep working straight across, what we just found is pi times r squared. The next thing we would need to do is take it times the height. We would take it times the height of 18, and then we would divide by 3. Well, what I notice is that height of 18 actually is divisible by 3. So rather than timesing by 18 and then dividing by 3, I can do this ahead of time, and I notice that 18 divided by 3 actually gives me 6. So instead of timesing by 18 and then dividing by 3, we can get away with multiplying by 6 and being done. So I'm just going to multiply by 6, and I'll have my answer. 6 times 6 gives me 36. 9 times 6 is, of course, 54, plus 3 more is 57. I have 0 times 6, which is 0. And then I have 2 times 6, which is 12. I got to put my decimal place in where it matters. Well, again, two numbers after the decimal place, so I need two numbers after the decimal place. 1,205 and 76 hundredths. Check to make sure my answer makes sense. I was doing basically 200 times 6, and I know 200 times 6 is going to give me that 1,200, and so it looks like this is a pretty reasonable answer, 1,205 and 76 hundredths. Again, I go back up and make sure I have my label. That's centimeters for our label, and then since it's volume, it's centimeters cubed. That's it today. It's a little scary kind of getting into some new prisms and new shapes. They're not even prisms, they're pyramids and cones. But like we said, because of the relationship exists, because if they have the equal base area and the equal height, they have 1/3 of the volume of that same prism, that really tells you very simply, we're doing everything we already did, but for cones and pyramids to find their volume, we take base area times height, but now we divide by 3. That should be enough to take care of you today as well as on your assignment tomorrow. Good luck.